MBA entrance test trainer. Also, I train for aptitude in general. I have taken the CAT 9 times with 99.9 times almost all of the cases, and I have a quant score of 99.99 percentile 5 times. So let's start with the concepts and questions on mensuration. The first question, it says that Tarun is planning to expand his rectangular garden by 2 meters on all sides, and the current area is 360 square meters. So rectangular garden, so this is a rectangular garden, and the current area of the garden is 360 square meters. And it's increasing by 2 meters on all sides. Now the length and the width are 9:10, so 9x and 10x, and hence the area would be product of the length times width, which is 360. So we end up getting x and x, so x squared, 10 cancels here. The x squared is 36 by 9, 4. So that means x is 2. So the dimensions are 9x, which is 18, and 10x, which is 20. So 20 by 18. Now if you increase the garden by 2 meters on all sides, that means 2 meters this side, 2 meters this side, 2 meters this side, 2 meters this side. Then what was 18 will become plus 4, so it will be 22, and 20 will become 24. So it will become a 24 by 22 dimension garden. And that the construction takes 20 rupees per square meter. So what is the area? Let's multiply. So how much is 24 times 22? So 24 times 2 is 48. 48 times 11. So 8, 528. Increase in area, 360 to 528. So 360 to 528, the increase is 168. So 168 is the increase in area, and for each you have to pay 20 rupees. So multiply with 20, so that will be the cost. So 3360. So that is option A. Let's move on to the next one. Question number 2. A certain number of squares of side half a meter are required to tile a floor 3 meters by 6 meters. So 3 meters and 6 meters, and you are using square tiles of half a meter. So if you take half a meter along the length, you will take 3 divided by half. So 6 tiles along the side, and along this, if you take half a meter, then 6 by half, that is 12 tiles along the other side. The total number of tiles is 6 times 12, 72. Each tile costs 3.5 rupees. The total cost 72 times 3.5, which is 7 by 2. So that's 36 times 7. So that is 252 rupees. Option D. Number 3. It says the total area of 64 squares is 784 square meters. So the boxes are surrounded by a white border of length 3 centimeters. So the 64 squares on the chessboard, the area is 784. So that means each square area is, okay, so 64 goes once, leaves 144. So 144 divided by 64. So that would be, or let's just divide fractions. We'll get a fractional answer. The 8s are 8 9s is 72, 64. So 98. 98 over 8. So that's 49 over 4. This is the area of each square. So height of each square will become 49 by 4 square root. So that is 7 by 2 centimeters. So if you have the 64 squares, that means 8 squares along this and 8 squares along this. So each side will become 8 times 7 by 2, 28 centimeters by 28 centimeters each side. Right? So now they are saying that you have to surround this by a border of length 3 centimeters. So you surround the boxes by a border of 3 centimeters. So that means It's kind of like this. These are the boxes inside. Okay, I'm not showing all of them. And the border has a length of, in this case it should have been a width of 3 centimeters. So this is 3 centimeters and 3 centimeters. Everywhere along each side it is 3 centimeters, right? So in that case, since this is 28, so 28 plus 3 plus 3, so 28 plus 6. So 34 centimeters should have been the length on each side of the chessboard. So answer should be 34. So possibly answer option A, mark it as 34. So that would be the correct answer. Okay. Since the border has width, not the length, width 3 centimeters. So basically 3 centimeters on each side.
क्यों चुप हो गया भैया? लोडिंग हो रही है क्या? वाईफाई सारा इसी समय भरता है।
So 3 plus 3. Okay. 6 would be added, not 3. Number 4. The sides of a square are increased by 40% and 25% to form a rectangle. To find the percentage increase in the area. So let us just take the square sides to be 100 by 100. So after increase, 100 would become 140 and this 100 would become 125. So we need to figure out what's the percentage increase. So what is 140 times 125? So 125 is basically 5 times 5 times 5. So let's just multiply 140 times 5, 700 times 5, 3500 times 5 would be 17500. But the initial area was 10000. Clearly the increase is 7500 by 100,000 by times 100. It would be 75%. So that is option C. An alternative approach is simply to use the successive percentage change formula and calculate. So 40 plus 25 plus 40 times 25 upon 100. 40 times 25 upon 100 would give you 10. So 65 plus 10, 75% is the answer. Number 5. Janvi has a rectangular garden 12 by 10 and she builds a path of 1 meter around her garden. To construct the path with square tiles of length 50 centimeters, how many tiles does she need? So we can just figure out what the area is. So it's 12 by 10 and path of 1 meter on each side. So that means 1 and 1. So this becomes actually 12. And this side also 1 and 1 extended. So 12 will actually become 14. So the total outer area, everything included, is 12 times 14. So that is 168. The inner area is 120. The area of the path is the subtraction, product difference of these two, 48 meter square. And each tile is half a meter, right? Side. Each tile has half a meter. So area is 1/4 square meters. The number of tiles is the total area by the area of each tile. So 192 tiles are needed. So that is option B. Number 6. Simran is walking diagonally along her square classroom in 6 minutes. Walk at a speed of 4 kilometers per hour. So 4 kilometers per hour converted to meters per second, or rather converted to meters per minute, because the answers are all in meters. So 4 kilometers is 4,000 meters. This is in hours, so converting it to minutes would be divided by 60. So this is meters per minute. In 6 minutes you have covered this. So multiplied with 6 minutes, that will give you the length. So that clearly becomes 400 meters. So the diagonal length is 400. The diagonal is 400. The area of the square can be thought of as half times square of the diagonal. So it is 200 times 400. So it's 800,000, 80,000 square meters. So that is option C. Number 7. The volume of two cones ratio is 1:3. So the volume ratio would be 1:3, means one volume is x, the other volume is 3x. So these are the volumes. So let us just keep volume as in terms of V. So that way it would be easier to denote. So the volumes of the two cones, so the small cone and the big cone, let's say the volume is V and 3V. Now the heights are given in the ratio of 3:4. That means if this height is, let's say, 3h, then this height is, let's obviously 4h. So the volume is basically 1/3 pi r squared, so small r squared times the height by the capital R squared for the big cone times this. So this is given to be 1:3. So from here we get r squared by capital R squared is equal to 4/9. So small r to capital R, or small cone radius to big cone radius, is 2/3. So that is the ratio of the radii of the bases. So that is 2:3, option D. 7 is option D. The given question is followed by 3 statements. Study the statements and mention which of the following is needed to answer the question. Any two of the 3. Okay. What is triangle? To find the area of an isosceles triangle, just knowing perimeter is obviously not sufficient. Okay. Just knowing the height is also not sufficient. We need the base. So if I know the height and I know the base, then I can obviously find the area. So 2 and 3 are enough to find the area. Half base times height. That's first problem. Second, if the base of the triangle is 6, what in this case ideally would mean is, in this triangle, the unequal side is 6. Okay? Because I could reorient the side and make this as 6 also, and that becomes the base. So that is not the case. So here, the unequal side is 6. In that case, the sum of the sides from the first statement is 16. So these two add up to 10. So that means the other two sides are 5 and 5. Now, if I have this case, so by knowing the perimeter and I know the base, so now I can drop the perpendicular and calculate from Pythagoras theorem what this height would be. And once I know the height, I can use half base times height and find the area. So that means 1 and 3 are also perfectly fine. Now I just need to check whether 1 and 2 are enough to answer. So let us just check. If I know the perimeter and the height is 4, so if the height is 4, and if this is x, and this is y and y, so I have one relation which says 2x plus y plus y. So 2x plus 2y, that's the perimeter, is 16. And I also know Pythagoras theorem, y squared is x squared plus 4 squared. So I have got two equations with x and y, and I can solve them. Once I know x and y, I know all the sides, and hence I can figure out what the area is. So statements 1 and 2 together would also be sufficient. So any two are enough to answer the question. So either you take 1 and 2 or 2 and 3 or 1 and 3, you will be able to solve for the area. So answer is option D. Number 9. A rectangle and a parallelogram are drawn on a common base between the same parallel lines. So you have one rectangle, you have one parallelogram. Obviously, parallelogram area is base times the height, and the rectangle area is clearly the length times the width, which is also the base and height. So the areas are obviously equal. It is that the common base is 11, and the perimeter of the rectangle is 48. So if this is 11, the other side of the rectangle is also 11. So that takes out 22. So the remaining is 26. That is 13. This is also 13. So area of the rectangle is 11 times 13, which is 143, which is the same as the area of the parallelogram. So the answer is option B. A circular wire of diameter 42, so radius is 21, and that circular wire, the long thin wire, is molded in the form of an equilateral triangle. Okay, so what it basically tries to say is there is a small wire which has been rotated in the form of a circle. That's what it tries to say. This circle is converted to an equilateral triangle. That means the perimeter of the two shapes are the same, the length. It's not a wire which has been like it's a solid wire in that sense. That's not they're asking. What they're saying is you have a wire which is kept in the form of a circle, which has now been deformed and converted to a triangle. Means the length of the circumference and the length of the perimeter are the same for these two shapes. Since the radius of this circle is 21, so the perimeter is 2 pi. We can take 22 by 7 times r. So that is 132. So the triangle perimeter is also 132. So 3 times the side is 132. The side is 44. So they are asking what is the side of the triangle. So that's 44 centimeters. So that is option D. The length and width of a rectangular unit are 8 and 15. Okay. The length of the rectangle is increased by 25%. So 25% increase means 1/4 increase, so it becomes 10. So the initial area is 8 times 15, so that is 120. Now the new length is 10. So if I have to keep the area 12, 120, so I have to convert the breadth or the width to 12. So that 10 times 12 is 120. So the percentage changes from 15 to 12, so that's a decrease of 3. The percentage change is 3 on 15 times 100. So that's 20% decrease. So that is option C. Now the picture. So you have a hemisphere. It's twice the side of a cube. Okay, so you have a cube. If I take the side S, then the radius here R is 2 times the side. You have to find the volume of the hemisphere and the cube. So volume here is clearly side cube. Here the volume is 2 by 3. So volume of a sphere is 4/3 pi r cube. Here it will be half of that, 2/3 pi r, which is 2s cube. Let's simplify. 2 cube is 8. So 8 times 2. So that's 16 by 3 pi s cube. So the volume ratios of the hemisphere to the cube would be 16 by 3 pi is to 1, which basically becomes 16 pi is to 3, And pi is 22 by 7. So if I substitute 16 times 22 by 7 is to 3. So you will end up with 352 is to 21. So that is option B. Obviously this double zero here is a typing mistake. So 352 is to 21 is the answer. Now it says find the length of a square whose area is 9 times the area of a square of side 10. So the square has a side 10. 10 by 10. So the area is 100. Okay. So the area of this square is 9 times. So that's 900. So square root of 900 is 30 by 30. So each side is now 30. So they are asking what is the length. So it is 30 centimeters. Option D. Question 14. It says that the floor of a room is 20 meters by 16 meters and it is to be covered with square marbles with sides 100 centimeters, basically meaning 1 meter side. So along the length you would need 20 by 1, so that's 20 pieces, and along the width 16 over 1, so 16 pieces. Total number of pieces would therefore be 20 times 16, 320 pieces. So that is option A.